All right, everybody, you know what time it is. It's time to complete the square. We still having some problems. Hmm. So completing the square is this process where you solve a quadratic, um, and you do it by kind of manipulating it to be a certain form, where you don't have this b squared and b in the same equation problem. You have something like b minus 2, for example, all of that squared, which means you can just take the square root of both sides. And what that's going to look like is, or the process, and when you would use this is when you're told to, or it's also where the quadratic formula comes from. So thanks to completing the square for that. But also if a is 1 and the function doesn't, if a is 1 and the function doesn't factor, and it's a really good method. The nice thing about it, in my opinion, is that with quadratic formula, you often have to simplify. You have to simplify and divide everything out after the end because the divided by 2a part, both completing the square, that part's done. So here's what you do. If there's a constant term, you just add it to the other side. Okay. And you're going to leave some space there. That's going to be a -1. Why are we leaving space? Basically, it's because now we are factoring, which is kind of weird. But how do you factor if you don't have a number at the end? Well, we know that the middle number is what would be at the bottom of our factoring tree. It's what our factors have to add up to, but we don't have a number at the top. We don't have a number there. So that's where the completing the square part comes in, is that we are going to create a number at the top. We're going to make there be a number at the top. We're going to say, you know what would be nice? If there was this number at the top. But you can't just add something to one side. You have to add it to the other side as well. So we're going to add something to both sides to make our factoring work out in our favor. The way it works out in our favor is if both of our factors are the same. So the only way that happens, the only way two numbers can add up to -4 if they're the same, is if those factors are -2 and -2. Well, what's -2 times -2? It's 4. That's the number that we needed to be here, and therefore we also have to add it here. Well, how does that factor? It factors to this, b minus 2 times b minus 2. And this is 3. This would be b minus 2 squared is equal to 3. Okay, and here's where I would say you can jump. We use completing the square in part, in no small part, because it's got such a strong pattern that you can skip some steps, basically. And this middle step is what I would skip. I would never write this factoring tree. I would always see that you can go from here to here. This number is half of the middle number. -4 cut in half is -2. The number we add to both sides is just the -2 squared, 4 and 4. So it's a very quick thing to see the pattern, is jump to that. And then once you've got that, you can do the square root of both sides now, which is why we do that in the first place, because it cancels out the square and leaves you with b minus 2 is equal to plus or minus the square root of 3. Remember, in the quadratic formula, -b plus or minus the square root. And so we've got the plus or minus part. Now we're going to add 2 to both sides. Sorry, my writing utensil is causing me some problems here. 2 plus or minus the square root of 3. And now we have completed the square. If you look at number 13, it's very similar, but the way the question is phrased at the top is the way you might see it on a test or on the final, where it gives you options and says, hey, when you complete the square, what is it going to look like? And that's that.